Okay, so since population variance, sigma square, is a population parameter, we would like to estimate it. Right? Now, a point estimation of the population variance is very simple. It's just simply s squared, which equals summation xi minus x bar squared divided by n minus 1. Right? So that is the unbiased estimator for the population variance. And if you want a point estimate, that's all we have to give. Now, for interval estimates, what's our goal, right? Our goal is we want to know, right? We want to provide, say, here, let me put our goal here, right? For interval estimate, we want to create an interval, right? We want to be able to say that sigma square is somewhere between an upper bound, right, and a lower bound, right? And we want to be able to calculate, right, what these upper bound and lower bound is to create, right, to create, say, say, all right, a 95% confidence interval, right? Okay. Now, to do this, right, we're going to take advantage of the facts that we learned, that we have learned or given, in our first two pages. So we know this, right? We know that this term here, right, is right, this term here, right, has a chi-square distribution. So then the idea is, well, if I have my alpha, and let's say my alpha equals 0.05, and then similar to conceptually it's the same, right? It's exactly the same as the interval estimation in a normal distribution with mu, and so similarly, I'm going to divide the alpha, right? I'm going to divide alpha in half into these two tails. Right? The only difference here is that chi-square distribution is not symmetric. I see in a normal distribution when here, like here as a reminder, in a normal distribution, right? If I do alpha half here, alpha half there, right? So my critical value is going to be z alpha half, and then here will be negative z alpha half, right? This will be the same. For example, if this is 1.95, then this will be negative 1.95, right? Because normal distribution is symmetric. The difference here is that the chi-square distribution is not symmetric, okay? Idea is the same, just the mathematically it's a little bit more, just a little bit more complicated. Okay, but we're going to take advantage of this, and then we're going to basically take this and solve for sigma square. Okay, put sigma square in the middle. Now, first thing we want to do is figure out what the chi-square, what these critical value is. All right. Okay. So let's go ahead and figure that out in the app. So we got chi-square of 0.975, okay, and then we have chi-square of 0.025. Okay, let's figure that out first. Okay, so now, I need a degree of freedom. Okay, actually, you know what? Hold that thought. Let's hold these. Let's hold these for now. Let's go ahead and what I want to do is solve for the inequality. Solve for the inequality first. Okay. Here I have again chi-square. Right. Now 0.975. Okay, so one needs to see that the reason why it's 0.975 is because everything to the right, right, the area to the right of this number is 0.975, and same reason why this is 0.025 is because area to the right of this number is 0.025. Okay, so that's what gives us the critical value. So instead of writing 0.975, what I'm going to write is it's here it's 1 minus, right? I'm going to write as a 1 minus alpha 1 minus alpha half, like so, right? Now, and then, so that's going to be 1 minus 0.025, so it's going to be 0.975. Less than or equal to n minus 1, s squared over sigma squared, right? Less than or equal to chi square of alpha half. Okay, now, yeah, what I'm about to show you here, basically, long story, if you skip all this, just know that at the end I'm gonna get to this. Okay, but don't worry. I just want to show you where this comes from. Okay. By the way, this is wrong. What? This is this should be 1 minus alpha half, not 1 minus alpha all half. Okay, and then so here, let's go ahead and here I'm going to divide both sides. I'm going to divide all three sides actually by n minus 1 and s square, n minus 1 s square, and n minus 1 s square. Okay, so that's going to cancel these guys out, and what I will get is chi square 1 minus alpha half, right, all over n minus 1 s square, and less than or equal to 1 over sigma square chi square alpha half over n minus 1 s square. Okay, now sigma square here is on the bottom. I want to flip it over. So I'm going to flip all three terms. I'll flip it around. So I get sigma square. However, and then here I'm just going to write it first. N minus 1 s square chi square 1 minus alpha half. Okay. Don't write the inequality yet. S square. All right. Now, why do how come I can't just write this? Well, because when you flip fractions over, the inequalities change. Okay. If you're not sure why that is, here, take a look here, right? So if I have 1/2, 1/3, and 1/4. Right? Now, what do I know? I know that well, 1/2 is bigger than 1/3, and 1/3 is bigger than 1/4. But if I flip it all over, so I get 2, 3, and 4. What happens? Well, it changes, right? The direction changes. I know that 2 is less than 3, 3 is less than 4. Okay, so whenever you flip fractions, you always have to change the inequality. So once I flipped it around like this, right, then there is my sorry, I forgot to write that. I forgot to flip this part over here, right? I'll have n minus 1 s square and chi square alpha half. Okay. All right. Now once I flipped it around, but so inequalities, right? Just by think of it as tradition. We always write the smaller number on the left, go it around. So we're just simply gonna flip this around, and then finally we get to this. We get to that as our interval estimation formula. Okay. And then if I want the interval estimation for sigma, then I'll simply take a square root of all three terms, and then I get that. Okay. So this is this is a confidence interval. By comparison, right? So for example, this is something that we're familiar with. For example, a confidence interval for mu. So remember how we calculated that? Well, we got x bar minus e and x bar plus e. Okay, again, this seems like a simpler, right? This is a simpler type of formula, but the reason why it's simple is because, again, a normal distribution is symmetric, so that the confidence interval, the x bar, the point estimate will be centered in the middle. But a chi-square distribution, it is not symmetric. Therefore, we need to use this formula to get the upper bound and the lower bound.